Hi, today we'll learn about vectors in physics. This is Naveen Hegde from vidyanilaya.com. What are scalars and what are vectors? Scalars are physical quantities which can be described completely using only the magnitude, whereas vectors are physical quantities which need both magnitude and direction to be considered for their complete description. You can say scalars as, for example, quantities which are independent of direction. Representation of a vector. A vector is represented by an arrow on top of a variable, something like this. Arrow is meant only to indicate that V is a vector and does not indicate the actual direction of the vector. Now let's see some of the vector algebra. Before that, we'll define what is a vector. Vector is something which has a direction. For example, only certain quantities have a direction. For example, speed is a scalar, whereas velocity is a vector. Speed defines how fast a quantity is, whereas velocity is the same thing with a particular direction. He is moving at so and so speed in that particular direction, means it is velocity. Similarly, let's go and see what's vector algebra. For example, addition of vectors, triangle method, parallelogram method, and subtraction of vectors. We'll see what it is in slightly. We'll see what it is right now. For example, let's say a vector v is in this particular direction, and another quantity, another vector is moving in this particular direction. What will happen is the resulting quantity will be the sum of both, which is something like this and this, which makes it, this is the triangular theory, which makes it this particular line, which is this vector, the vector v plus vector, let's say v1 and v2, will be equal to vector v3, which has a direction of this direction. So this is how you add different vectors. Now let's see how you subtract a vector. For example, this is the direction of a vector, then the negative of this vector will be this particular vector. So as you can probably assume, a vector which has this much magnitude v1 minus this v2 will be just this vector plus this same vector in the opposite direction, which is like this, which will be equal to about this much. So this is how you do the negative of a vector, or how you subtract a vector, etc. Now let's see the parallelogram method of addition and subtraction, etc. Let's say you have physical quantity like this, or you have a vector like this, and you have another vector in this particular direction. Then the parallelogram method is where you do it from the same point. For example, from this particular point, make a pivot and then attach both the vectors like this, and you make a parallelogram out of it, and you connect the diagonal. So this particular quantity, which is this line here, makes it the addition of this vector v and this vector v2, v1 and v2. So this is how vector addition and subtraction happens in vector algebra. However, if you go to the standard definition of how the without the direction happens, it is vector into components. For example, a vector A or a vector, in this case R, can be defined as the x component of R as well as the y component of R. A of x is equal to a cos theta and a of y is a sin theta, which means simply that if you don't have a knowledge of trigonometry, I'll just move to that as well. So if you have, for example, y by r is defined as sin theta in trigonometry, which is opposite by hypotenuse, and x by r, which is adjacent by hypotenuse, is defined as cos theta, and y by x, which is opposite by adjacent, is defined as tan theta. Similarly, what happens is if sin theta is y by r, then y is r sin theta. How does that happen? When you just move it around, for example, let's say you have theta here, then sin theta is opposite by hypotenuse, which is nothing but O by h equal to sin theta. Now this quantity will come here and make it O is equal to sin theta into or multiplied by h. This is how, when you want to define h or when you want to define O, this is the component in y-axis. That is why h y component is defined as h sin theta. Similarly, h x component is defined as h cos theta. Now I'll just show you a shortcut of how to use these things. For example, if you have theta and if you have adjacent, then cos theta is nothing but this particular line which has a shadow in this direction, which is nothing but all this, which is, you just slightly move this thing and make it the x component. Similarly, what is sin theta is this particular component in this direction, which is h becoming somewhat like this, the x component or the y component. Sorry. So the shadow of this particular line in this direction will be something like this, which is the opposite. So that's the shortcut I was talking about. For example, y is nothing but r